2 plus 5 plus 8, so forth and so on, until you reach 41. Now that's a beautiful problem to sort of bring in what we're talking about here. Sort of close this down, at least this part. Guys, add those up. You don't have the time there to add those up directly, it takes too much time. I'd like to rewrite this with your help with the sigma notation to indicate that they're asking me to sum up. And I will start out with 1 at the bottom. We usually do. And then I have to decide what to place on top, and then I need a formula inside. Can anyone help me with the numbers 2, 5, 8? There's a pattern there among the numbers of that series. Goes out to 41. And they're saying add all those up and get a grand sum. And anyone think by just observing this, could you come up with a formula like A subscript n is equal to, what would you like to use here? You want to have an idea? Now I see the first few numbers differ by 3. So there must be a 3 involved. 2 to 5, 5 to 8, and so forth and so on. Jonathan, got something in mind? 3n minus 1. Let me put this in blue so you guys can see it. 3n minus 1. Okay, Jonathan, you're right. If I replace n by 1, I'm using a k over here. I just put an n. Nice. If I replace n by 1 in this formula, I get a 2. So a 2 in there, 6 minus 1, I get a 5. 3, 8. That's the formula I need. 3n minus 1. It's correct. Now, with some good thinking there, I need to know what should I place on top? What's my stopping point? Can anyone tell me a clever way to find it?
So 3n minus 1.
That 3n minus 1 that Jonathan gave me, when it finally becomes what, 41? I can solve for n. So when I finally reach that value of that last term, which is 41, with his help, I got 3n, and Mike will ask me to do this, 42. Guys, I think it's 14. So the top is 14. And that's what it comes down to. Now let's try to find the sum with the sum formulas. So guys, when I split this up, I move the 3 out front. I've erased the formulas, but we should know what they are. I'm going from 1 through 14 of n, subtract, summation, from 1 through 14 of 1. Step back and look at it on top of the board here. Does that look reasonable? If we separate correctly. This one, guys, is 3 times, here goes, you're not going to be able to do it unless you use a formula. The summation for n is n times n plus 1 over 2. And since I have limited time, it's 14 times 15 all over 2 by a formula you saw before the break. Do not let me mess up. On the end, this one looks like the formula c times n, cn, which is merely 14 times 1 is 14, and that one's done. Finish it up, go back and clean this up, guys, the best you can. Lots of ways to do the math here. I'm going to cancel 2 into 14, get a 7. Inside there, 7 times 105 is 105. I'm doing the math in my head here, guys. Then 105 times 3, is that 315? Because 315 subtract 14, if my math is correct. Looks like it's 301. I did that real quickly. Is that true? So that's the sum of all this, is 301. And if you don't believe the formulas, add them up correctly. Take a little time. Okay, so it looks like the sum is 301. I'll point that out from the handout and closing down. Now, I want to point out something a little unusual. I think it's letter, I think it is. Not letter D on the handout, guys. Letter D. Can't work all these, but we'll work it up. Now, sometimes you'll see a summation that looks really strange. This one does. it's saying, please start out with, yes, k is equal to 1. And then all of a sudden you see this, which will actually drive you nuts. You see the infinity symbol on top, which means sum forever. Not a set number at the top, but infinity. And then on my particular example, I have 3/10 inside here. That was given to me. And 1/10 raised to the k minus 1. I'd like to know what on earth is that? And I don't have particular formulas for this one. Before you took the break, did I have the formula listed over there with an infinity at the top? No. So it says sum forever. This is infinite. It's a series. Okay, here goes, guys. We'll write up here the terms out. I replace k by 1, I get 1/10 raised to the 0, which is 1, times that 3/10. So my first term is 3/10. We add another term, that's when k is 1. When k is 2, replacing k by 2, I get 1/10 raised to the first, which is 1/10, times 3/10 is 3 over 100. At least I'll see what the terms look like. Okay, 1, 2, let's try 3. Put a 3 in there, becomes 1/10 squared, which is 1 over 100, times that 3/10 out front, would be 3 over, I guess, 1,000. And they're telling me, please do this forever. Oh boy. Does anyone have in this clever class, after you see them expressed, and you can write 4 terms, 5 terms, 6 terms out if you wish, it goes forever. Does anyone see, though, with the limited number of terms I have, something going on here? Which might lead me into a simple answer. Does anyone see? You're trying to add 3/10 to 3 over 100 to 3 over 1,000. I'm assuming the next term might be 3 over 10,000, and it continues like that forever. They're asking, what is the grand sum? Okay, here it goes. Some student may have an idea. I know, and you know, I could express this in decimal. 3/10 means this, guys. That's 3/10. It says add to it, the second term is 3 over 100, which could be expressed like this. Then add to it 3 over 1,000, which could be expressed in decimal like this. And it continues forever. Right now at this point, with my 3, I've got a point 3, 3, 3. And since I'm supposed to do this forever, add through infinity, looks like I'm going to end up with point 3 where the 3 continues to repeat. Now, can someone tell me from middle school, what do you recall from middle school that gave you 0.3 as a decimal with 3 repeating? And that's the answer for the blue. That's the summation. Does anyone recall what gave you back in middle school 0.3 and the 3 repeated? No. 1/3. The fraction 1/3. Is 0.3333 in decimal. That true, guys? Even if you try to divide 3 into 1, you'll get a string of 3s. That's exactly what this gave me. So right here is merely middle school, and what's the answer? 1/3. Now, if it came out to be something strange in a Math 8 class or a Math 11 class, and not like this, I swear I had this rigged, but it would work out for me. If it doesn't work out though, I have to give you a formula to work with. Right now though, I had to point this out. Now, before I leave it, all I'll expect you to know is something like this. Please tell me someone, what on earth do you think, if you're asked to add through infinity of this? I'm trying to think of a nice one here. Let's create something real quickly. Like that. Let's try one more. One over 9. Any other possibilities? I'm going to write a few of the terms out. First term, replace k by 1 would be 9/10. We'll replace k by 1, guys, I get 1/10 raised to 0, which is 1. So altogether, the first term is 9/10. If I replace k by 2, right here, I end up with 1/10 to the first times 9/10. That'd be 9 over 100. Let's try one more. Replace k by 3 in this one, just because 1/10 squared, which is 1 over 100, times the 9/10 is 9 over 1,000, and this is supposed to be going forever. That's what it means. Now let's see if I can do what I do for the 1/3. Guys, this is 9/10. This is 0.09, add to it. This is 0.009, is it? True? And it continues like that? So even at this point, if I add these up, please tell me, do I get 0.9 where the 9 repeats? Is that what it means? 0.9 where the 9 repeats? Anyone tell me, what do you think we accept in mathematics as an answer for that? Middle school over here said 1/3. What do you think we accept here for a 0.9 where the 9 repeats forever? What do you think we accept for an answer? 1. You have a string of 9, 0.9999999, and we accept in math, if that happens, you're adding forever, accept the answer as 1. 1/3 on the first one from middle school, this one, 1. So I thought I had to point that out for you guys, believe me. Now that said, oh boy, here goes, am I ready? Yes, I am ready. Okay guys, here goes. I'd like to point out, to lead me to where I want to go here. This is part 2. Close all this down. Let me rewrite something I had earlier on the board. I'm now ready for it, I think. I'd like to write this out. Summation. And looks like I started out with J, and use a J here, with 0, through 2. To choose J. Looks like I have, let's see if I can have it. I do x raised to the 2 minus j, y raised to the j. I like to know what on earth is that crazy expression telling me. I see a summation, there's somewhat on here. Okay guys, I'm gonna write the terms out. Now this was written in terms of J, and I think I used the J before the break on something. The guys, it says start with 0. Replace J by 0, then replace J by 1, then J by 2, and you'll be finished. So 3 terms. Let's see what the first one looks like. First one, replace J by 0 is 2, choose 0. X raised to the 2 minus 0, y to the 0. That's my first term. Now let's let J be 1. I've got to build it up to 2. Put a 1 in there, it's 2, choose 1. X raised to the 2 minus 1, y raised to the first. That's my second term. J being replaced by 1. Now J being replaced by 2, which is the top. I've reached the top there. That's my last. So it's 2, choose 2. x raised to the 2 minus 2, y to the second. That's the way the three terms look. Now, like, what on earth is that? They're going to be shocked what this is equivalent to. Okay, guys, here goes, and I'll tell you the response I'm going to get here is a middle school response. Doesn't look middle school right now. So, guys, here goes. 2 choose 0. We'll use the formula. The formula 2 factorial over 0 factorial 2 minus 0 factorial. That's n factorial, j factorial, n minus j factorial we saw before the break. I'll come back to it. Of course, x squared comes in, and y to the 0 is 1, so my first term at this point looks like that. Just clean it up. Next one says 2 choose 1. Well, it's 2 factorial over 1 factorial over 2 minus 1 factorial. And that's x to the first, y to the first. Next one, 2 choose 2 from before the break. 2 factorial over 2 factorial to subtract 2 factorial. As x to the 0, y squared. Looks strange. But again, you're going to be shocked what we get. So guys, make sure I use that formula correctly from before the break. Now, let's finish this up. 2 factorial, of course, is 2 times 1. 0 factorial, by definition, then should be a 1. Let's place a 1 there. And we got 2 factorial again on the end. 2 times 1. I think we all see what's going to happen here. In the first term, everything cancels into a 1. So I have only merely 1x squared for my first term. I have a y over here. I don't have a y in that first term. Y raised to 0 is 1.
X. Okay.
Is that true, guys? Everything is that correctly? Well, is it? We'll find out. Next one says this, 2 factorial, oh boy, I gotta do it right here. 2 factorial over 1 factorial, which is 1. Let me go ahead and write that as 2 times 1. 1 factorial, 1. And 2 minus 1, 1 factorial, 1 again. Guys, if I do my factorials correctly and do the math with the help of the formula, I think that's a 2 altogether. I think. So that gives me, let me erase it, guys, we're running out of space here, right here, my formula. All that comes to be a 2. So my middle term is this, 2x to the first, y to the first, or merely 2xy. This is the second term. Last term, only 3 terms, thank goodness, is 2 factorial again, which is 2 times 1. These factorials at least are easy. Again on the bottom, 2 factorial. 2 subtract 2, 0 factorial, which is 1. It's going to be 1. I think, guys, everything cancels there again. X to the 0 on the end is 1. Y squared. So I think after all that, we do a little erasing. We did the calculations. I think that first term really comes out to be y squared. Yes or no? Now, can anyone tell me from middle school, what is x squared plus 2xy plus y squared in factored form? Anyone factor that middle school problem? X squared plus 2xy plus y squared. X plus y quantity squared. Those kids across the street know that. They would not know, I don't think, that this is the same. This is equal to this. Who on earth would think? Not in middle school especially. Who on earth would think? You saw that miss there? It says this. It's equivalent to a middle school response. Because they don't see it like this, for sure. Okay? Now, that's going to lead me into the closing down here shortly. Something called, I'll give you a name for it, binomial theorem. And you and I are going to close this down here shortly. It's called binomial theorem. Binomial, two terms. X and a Y here, binomial. And it says in the binomial theorem here, a way to express squared, cubed. Raise it to the fourth, raise that binomial to the fifth. But do it with these summations if we can. Okay, so it's called binomial theorem. First, guys, I'd like to, with your help, take a binomial from middle school. Let's make it look fairly simple right now. Let's make it x plus, let's say 2. Raised to the fifth. X plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. And you may look at the clock and say, Professor, we'll be here the rest of the evening to do this one problem because it is way out there. I got to do the distributive property, distributive property, distributive property, or we're going to run out of time. No, we're not. We're going to try to make it easy here. Now, I put a 2 inside there. I know here my result came out to be x plus y squared. You can put a 2 in there if you wish. To make it correspond with what I've won here, we'll change the 2 right now, guys. Let's expand. What on earth is x plus y? X plus y times x plus y times x plus y out 5 times. And if I visualize doing that by the middle school process, it would take forever. Okay, here goes. Can anyone tell me how many terms do you think will be in the expansion when I finish it? I notice over here, when I took x plus 2 squared, I think we ended up with 3 terms down here. So I took this binomial, 2 terms, x plus y. When I squared it, I got 3 terms. Give me an idea of what I may, how many terms may I get when I take x plus y, and this time I want to raise it to the 5th. How many terms do you think I'll get? Well, it looks like this one, I'll give you another hint. I'm going to get 1 more than the exponent. Here is x plus y squared, and I got for my response 3 terms. Did I get 3 terms? On x plus y squared, so I will always get 1 more than the exponent. So I'm going to make room for it right now. Show, just in case, we're supposed to have 6, let me count. 1, 2, 3, 4, 5, 6, we got 6 terms. Now a little common sense. Let's try to fill in those 6 terms. I know and you know, if I'm trying to write out x plus y times x plus y times x plus y 5 times, common sense tells me the first term, Professor, it's got to be this. And the last term, Professor, no question, it's going to be this. Is that true? The first term's got to be x to the 5th. The last term's got to be what? Y to the 5th. Now, in between here, okay, let's see what we do here, guys. I might think, help me out here, guys. Tell me in terms of x, what do you think the next term here would be in terms of x? What would the x look like? Just the x. I start out with x to the 5th. What do you think would be here? And here. And here. In terms of just the x. As I fill in the blanks. Get an idea. Thank you, I heard it. You think maybe it drops down 1 x to the 4th. Then maybe what? X cubed, x squared, x. Those are my x's. Filled in. Now, I notice on the end we have a y to the 5th. Let's go backwards. Give me an idea, what do you think in terms of y? What may have been this term here? Now we're going backwards on the y's. The n term we think is going to be y to the fifth for sure. In terms of y, what in the previous term? Do you think? Y to the what? Fourth. Y cubed. Y squared. Y. Is that making sense? With the x's placed in there, then the y's placed in there? Now for a quick check, before we go further. Quick check is, the original exponent was 5. Yeah, I got a 5 here. If I add these exponents up, 4 and 1, do I get a 5 here? And here 3 plus 2, 5 again, 2 plus 3, 5 again, 1 and 4, 5 again, 5 again. There's a little check, they're all 5s. Now what's missing are the coefficients out front. I'm assuming this is going to be a 1. And I would assume maybe the last term also the coefficient stuck out front is going to be a 1. And there's some coefficients missing on the other terms. I need a way to come up with those terms. So you guys can step back and look at it. Here we go. Am I ready? I am ready. Here we go. Something that you probably have seen before, and I'm bringing in right now. Something called, for help here, Pascal's triangle. Some of you guys may have seen it, I may have forgotten it. Another mathematician, Pascal's triangle. A triangle with numbers that has a pattern in it. The triangle looks like this, guys. The tip of the triangle is 1. Second layer is 1, 1. I'll make it look like a triangle. Third layer, 1, 2, 1. Next layer, 1, 3, 3, 1. We'll do another one. 1, go out here, 4, 6, 4, 1. And it continues. Now there's a pattern also in the numbers in the rows of that triangle. I need to fill in another row here with your help. If I said continue, this triangle continues forever. Would I expect, now I'm running out of space here, guys, would I expect a 1 again out here and a 1 out here for sure? Great looks. Now does anyone see, based on what I've given you here, a way to come up with the missing terms based on what I gave you here?
5.
And we'll fill in. Here at 5. How'd you get a 5? 1 and 4. What's 1 plus 4? Is that going to give me a 5? Like up here, it's 1 plus 3, wasn't it? Give me a 4. 3 plus 3 in the previous row there, give me a 6. 3 plus 1, give me a 4. And of course it ends with a 1. So I would think now, as I look back, guys, I got a 1 here. Looking back, 1 plus 4, am I expecting a 5 here? What's my next term? 10, 4 plus 6. 6 plus 4. 4 plus 1. There's my numbers. There's a pattern within this triangle with this mathematician Pascal. Let me write another row of numbers. 1 for sure, 1 here. Triangle goes on forever. Let's get the remaining numbers here, guys. 1 plus 5 will give me a 6. Just in blue to keep it consistent. 6 here. Looks like 15. Do not let me write something down wrong. 20, 15, 6, 1. Are those correct? Did I write down the numbers correctly? The rows there, it's this pattern. And it goes on forever. Now, I'd like to, with help of Pascal, see if my coefficients are missing here. I'm raising something raised to the 5th power. This is the one at the top represents something being raised to the 0 power. It's called x plus y. That's 1. This layer represents x plus y, binomial, raised to the 1st power. 1x, 1y. That's what those ones represent. You have 1x, 1y. My next layer x plus y binomial squared. Which I think I did here. And I got coefficients of 1, 2, 1 back here. And I think the triangle says 1, 2, 1. That's true, guys? Now I want to finish mine up with 5 over here. X plus y raised to the 5th. So I got 0, 1, 2. I've got to be careful myself up here on the board. 2, where am I? I've got to do 3. Was this for 3 here, right here, guys? 3, and this one's for 4. Are these the numbers I need for mine? Or this for x plus y raised to the 5th down here? So I got 1, 5, 10, 10, 5, 1. Put those in. 1, 5, 10, 1, 5, 10, 10, 5, 1. And there's your x plus y times x plus y times x plus y times x plus y. Finished. Aaron, here's a quick check. I'm going to show you something you do if you see this in a math 7 class. Rather than going to Pascal's triangle, I love Pascal's triangle. Pascal's triangle is fun to work with. But they may not accept that it works. It looks like it's too middle school. Here's another way to do it. If you want to find out what the missing parts are, let's go back to the previous term here, guys. You multiply 5 times 1